So if we have this example right here, the first thing we want to do is add 1 to both sides, because most of the time we want to isolate the radical. Okay, so same kind of steps as when we're just solving a regular equation. If this is something we don't know, get the stuff that we don't, or that we do know, away from what we don't know. So add 1 to both sides. This gives us the cube root of 2x minus 9 equals to 4. Okay, now what would we like to do? Cube both sides. And we're cubing both sides because we're trying to undo the cube root. And the way we undo a cube root is to cube. Okay, so if I cube both sides, what do I end up with on the left-hand side of the equation? 2x minus 9. Now, when we first saw this, some people were trying to cube the 2 and cube the 9. Except, remember with our whole exponent rules, this is really something to the 1/3 power, and then we're cubing it, so that just takes the exponent away, and what we're left with is whatever was inside of the root. Do you remember that? Okay, so equals what? 64. Okay, now what are we left to do to solve it? Add 9. 2x equals 73. If I divide both sides by 2, what do I get? Bit later? Can we do it after? Okay, perfect. X equals? Oh, see, this must be wrong because we're getting a decimal as an answer. Well, won't we know for sure if it's wrong in just a minute? Okay, so what do we end up with? How about 36.5? Okay. How do we know for sure if it's the right answer? Plug it in. Okay. So 2 times 36.5. Guys, if we just had 73 divided by 2 and we got 36.5. Okay, so 73 minus 9. 64. What's the cube root of 64? 4. 4 minus 1. Oh, does 3 equal 3? Genius. We good? Okay. So that was from yesterday, right? This example is also from yesterday. Just as a reminder to get us back into the swing of things or something. What do we want to do first? Is the radical isolated? Yeah, so let's get rid of the radical. Why are we squaring this when we cubed the last one? It's a square root, right? So if I square that, I also have to square the other side, right? Okay, so let's do things a little bit backwards. What do we end up with on the right-hand side? Just 7x plus 15, right? Okay. Yes, ma'am. Oh, that's a good question. Okay. Why did I not put x plus 1 in parentheses? But you just told me that it can't be squared, but then you just squared it. Okay. Wouldn't it actually help if I did put it in parentheses? Aren't you more likely to remember what to do if you'll go ahead and put it in parentheses? Because I'm really squaring this whole side, aren't I? Remember yesterday we talked about the fact that we're not just squaring x and squaring 1, and if we do that, what will happen? Yeah. Every time we'll get it wrong, right? Sometimes even the distributive property police will come for you because that's illegal. Illegal. Okay? So what's actually happening when you square something? You multiply it by itself. And if I multiply it by itself like this, we distribute. That's exactly right. X squared plus 1x plus 1x plus 1. If I combine my like terms, and that's what actually goes on this side of the equation, doesn't it? x squared plus 2x plus 1. Now what do you think I should do next? I probably want to get it equal to 0, exactly right. Why do I want to get it equal to 0? Well, I've got a squared and an x, right? So I need all the x's together on one side. I can't just put the x's on one side and the constants on the other because that doesn't help me here. I need everything on one side so that I can eventually, probably, hopefully, factor. Okay, so let's go ahead and subtract a 7x and subtract a 15. What does that give me? X squared minus 5x, perfect, equals 0. Is that a trinomial that I can factor? What multiplies to be negative 14 and adds to be negative 5? Negative 7 and positive 2. What do I do now that I have my factors? Remember our thought process? If I have two numbers that are multiplied together and that equals 0, it has to be true about at least one of these numbers. It has to equal 0. So we set them both equal to 0 to figure out what x makes these 0 so that I can get an answer of 0 if I multiply them. So I say x minus 7 equals 0 and x plus 2 equals 0. X equals 7. X equals negative 2. Are they right? I mean, should we really check? Does it really make that big of a difference? Oh, yes? Okay, all right. So 7. 7 plus 1. 8. Okay, 7 times 7. 49 plus 15. 64. That's right. Square root of 64. 8. Okay. Cube root of 64 is 4 for the record. Square root of 64 is 8. Does 8 equal 8? Okay. Negative 2 plus 1. Negative 1. Okay. 7 times negative 2. Negative 14 plus 15. It's 1, right? What's the square root of 1? Does negative 1 equal 1? Did we do something wrong? Those of you who were here yesterday, do you remember what that's called? I'll let you say it if you say it correctly. Last period said it incorrectly, and it was quite hilarious. It's called an extraneous solution. It's an extra solution that we got that doesn't work. We created it by squaring both sides, by adding that kind of dimension to the problem, and that helped us get the actual solution, but this one actually doesn't work. Okay? So this right here is our answer, x equals 7. Just for the record, they said extraneous. And I was like, that's way too close to something else, and we need to stay away from that. Okay? All right, are you ready for today's? Okay, here's today's. So I've changed it up. Harder or easier? Most people think it's harder because there's two radicals, right? Can I please respectfully prove you wrong? Okay. You just want to square both sides? And if I square both sides, what happens to the radicals? Oh my gosh. Harder or easier? Way easier, right? Okay. So now I just have, since there's only an x term, there's not an x squared term, do I get this equal to 0? No. I want all the x's together on one side and all the numbers together, the constants, right? So how about if we subtract x from both sides? And how about if we subtract 5 from both sides? 2x minus x, that's x. 5 minus 5, that's 0. X minus x, that's 0. 7 minus 5, 2. Is that the right answer? Well, we should check. 2 times 2, 4 plus 5, 9. Square root of 9. Try again. The square root of 9 is 3. The square root of 9 is 3, not 81. The square root of 81 is 9, but not the other way around. Okay? You're forgiven. You're forgiven. It's okay. 2 plus 7. 9. Square root of 9? 3. So here's what I want you to understand. I'm going to use this example as something that you might see in your homework that I want you to not panic about. Okay? What if I put this number in and did the math and got square root of 13? I know that I don't, but what if I did? Do you know the square root of 13? Yeah, neither do I. I know it's between 3 and 4, but I don't know exactly what it is. But that's not the point. Okay? If I put this in and get square root of 13, what do I need on the other side? And as long as it's the square root of 13 on the other side, I don't have to care exactly what the square root of 13 is. Does that make sense? So just be careful of that, okay? So I'm going to go ahead and underline that because I checked it and I know it's absolutely correct. All right? Okay. One more. What do you want to do first? What do you think most people want to do first? Subtract 1, right? Most people want to subtract 1 here. Is that going to help me at all? Because it's just going to move to the other side. I'm still going to have a number outside, right? So how about if we square both sides? Okay? Trinity, should I put a parentheses around the side? Most likely it'll help me remember what to do, right? So let's look at the right-hand side first. What am I going to get when I square 3 minus x, or the square root of 3 minus x? I just get 3 minus x, right? Okay. What happens if I square this side? Don't I have to do this like I did on the last example? I do, right? I have to square the whole side, and squaring the whole side means I have to multiply it by itself. Now, I'm going to ask you to please be patient with yourself on this example. And please be patient with myself. Okay? If I'm going to distribute, the first thing I have to do is that, right? What do I get when I multiply the square root of x plus 2 times the square root of x plus 2? What do I get? Don't I just get x plus 2? What did I get when I squared this square root? Just what was inside, right? Isn't that the same thing that is happening here? It's written like the square root of x plus 2 times the square root of x plus 2, but isn't that the same as squaring it? Yeah? Okay. What do I get if I multiply a square root of x plus 2 times 1? What do I get? Guys, what's anything times 1? Just itself, right? So I get the square root of x plus 2. What about 1 times the square root of x plus 2? What do I get? Same thing, right? And then what's 1 times 1? 4. It's not 4, it's 1. He was teasing. Okay? Now, before I go on, I need to make sure that you understand something. Okay? What if this number right here was actually a 4? What do I get when I say 4 times x plus, or square root of x plus 2? Do you know that I would get 4 square root of x plus 2? I would. Okay? If I'm multiplying a constant times the square root, I just put that constant out in front and I get 4 square root of x plus 2. You okay with that? Okay. What do I do now? Combine my like terms. What are the two most obvious like terms? 2 and 1. Does anybody know what 2 plus 1 is? It is 3, and again, that took entirely too long. Okay? For the record, I was talking with someone who is taking a college class right now, business math class, and they were very discouraged because while you guys know, at least I hope you know, that I'm pretty much teasing when I say, does anyone know what 2 plus 1 is? Because I'm pretty sure you all know. In his class, literally that's what the professor is saying. Does anyone know what 2 plus 1 is? And sometimes nobody answers from what he said. Okay? That's kind of the math level of the people in the room with him. So he's kind of discouraged, so we kind of gave him a little pep talk to keep up the good work. Okay? But if you guys actually know what 2 plus 1 is, you're apparently ahead of the curve. Okay, so keep it up. So right now I have x, and then I also have plus 3. Is everybody okay with me there so far? Do you realize that these are also like terms? Okay, if I have 1 square root of x plus 2 plus 1 square root of x plus 2, how many do I have? I have 2 square root of x plus 2's. You okay with that? So you remember a minute ago when we pretended this number was actually a 4? If I had a 4 plus x plus 2 plus 4x plus 2, what would I have right here? 8. You okay with that? Good. So this, can I simplify this any further? No. So it's what actually goes over here. X plus 3 plus 2 square root of x plus 2. Sorry about that. So now what? Now remember, think about this for a second. When do we make it equal to 0? If I want to try to factor it, right? That's when I have for sure like an x squared term and an x term or something like that. I still have a radical in here. Can I go there yet? Not quite. What do you think I want to do to that radical? I want to try to get it by itself so I can square it. Okay? So what am I going to do to get it by itself? So let's subtract an x and let's subtract a 3. That's a very good point. Subtract an x and let's subtract a 3. Because that at least starts to isolate it, right? Okay? So x minus x, 0, right? 3 minus 3, 0. So I have 2 root x plus 2 equals 3 minus 3, 0. Okay, so this has become an issue today, so I want to make sure to write some notes over to the side about it. Okay? We're going to do it as it comes up. So I want to say negative x minus x equals what? Negative 2x. Because, right, it's really the same as negative 1x minus 1x. So that should be negative 2x, correct? Is everybody okay with that? Okay, so negative 2x. Now what do you think we would like to do? Okay, so we have two options here, right? We have two options. We can either square it right here, or we can divide it by 2 first. We kind of had this conversation some yesterday, didn't we? Okay. Are either one of them wrong? No, but if I divide by 2 first, it makes our number smaller, doesn't it? Now, with numbers like 2 versus 1, it's not really that big of a deal, all right? But let's go ahead and divide both sides by 2 because it will make it slightly easier for us, okay? 2 divided by 2 is 1. So I just have the square root of x plus 2 on the left-hand side. What do I have on the right-hand side? If that simplifies to 1, I have negative x. Now what would you like to do? Now we want to square both sides. Okay? Trinity, you think we should put parentheses over here? just to make sure. Okay. On the left-hand side, what do I get? X plus 2. What do I get when I say negative x times negative x? Negative x times negative x. So a negative times a negative is a positive. What is x times x? So if I'm multiplying like bases, what do I do with the exponents? So 1 plus 1 is 2x squared. Do you see the problems that this can create if we mess those up? So just be real careful with yourself there, okay? So this equals x squared. Now we want to get it equal to 0. Okay? Because I have an x term and an x squared term. I can't just put one on one side and the other, whatever. So what you need to understand about me is that if at all possible, I almost always want a positive x squared. It makes things a whole lot easier. So even though it's only one step to move this over here, that would give me a negative x squared term, wouldn't it? So I would rather move the x and move the 2. To me, that just makes it easier when I'm factoring. Do you know two numbers that multiply together to give me negative 2, but add to give me negative 1? Negative 2 and positive 1, that's correct. What do I do with both of those factors? I set each one of them equal to 0. Good. So if I add 2 to both sides, x equals 2. If I subtract 1 from both sides, x equals negative 1. Are they right? We should check, right? Okay. So we'll start with the 2. 2 plus 2. 4, square root of 4. 2 plus 1. 3. So that side is 3. Okay. 3 minus 2. The square root of 1. Does 3 equal 1? No. It's not an answer. What's the first thing that a lot of people do when they do that? They either assume the next one's right or they assume they did something wrong. Right? Don't assume that. You might have done something wrong, but the chances are you got it right. That's just an extraneous solution. Okay? Let's try negative 1. Negative 1 plus 2. 1, what's the square root of 1? 1 plus 1. 2. 3 minus a negative 1. Positive 4. What's the square root of 4? Does 2 equal 2? Then that one is a correct answer. Okay? Now, I did this example on purpose because, where's that other one? A lot of times, because of this example I did for you earlier, what do you think an assumption that people make is when they get answers like this? The negative one is always wrong. Okay? At least in my experience. When this happens, they're like, oh, the negative one's wrong. Well, look, the negative one was the right one. The positive one was wrong. So you can't just always assume that it's the negative one that's wrong, because sometimes it's the one that's right. Okay? Any questions on this? How do you feel about this? Guys, was this one hard? But it was long, time consuming. Okay? Did you understand every step that we did? Could you recreate every step that we did? Yeah, there was just a lot of steps. So, again, please be patient with yourself as you're going through these problems. Okay? Any questions? If you do, what do? Ask. Excellent. Peace.